students, yes, we all know the challenges and situations that we are facing as far as this pandemic is concerned. However, we are not going to make it a big challenge. We are going to introduce you to some learning materials by way of video lessons. So I would advise you to just get a pen and paper, so that as you are watching, you also be putting some things down. Don't forget that you are still students. In no time you'll be writing your exams. So make good use of this opportunity. Alright. So we'll be looking at mensuration. I'll be talking about some few aspects about it, which involves perimeter and area. Perimeter and area. We'll be looking at these two. I want us to center much on a sector, because I've been seeing that most students find it difficult when calculating area and perimeter of sectors. So let's look at the area of a sector. Now, before that, you should be able to know what a sector is. When you say a sector is a part of a circle, which is bounded by two radii and an arc. So assuming this is a circle, let's take this one to be the center of the circle. So if I draw any line from the center to tie the circumference, it's a radius. If I draw another line from the center to tie the circumference, it's also a radius. So I'm having, let's represent the radius by r. Here is r, this part too is r. So the angle formed by the two radii, I'm giving it theta. Now you should note that this shaded portion here is a sector. It's a sector. So a sector is a part of a circle bounded by two radii and an arc. An arc is any part of the circumference. If you look at the circumference, any part of it is called an arc. So if I label here AB, I can call this one arc AB. Arc AB. Center O. So in short, AOB is a sector. Alright. The unshaded portion is also called a sector. The part that I have not shaded, this portion is also called a sector. So I'll call this one the major sector, and call the shaded portion to a minor sector. So the difference between the minor and the major sector is that the angle bounded by the two radii will not be the same. So take notes. If you are finding the area of a sector, the angle that you are going to use for the minor sector will be different from that of the major sector. So it's very, very important for you to notice the type of sector that you are finding, whether it is a minor or the major, so that you not get mistake by using the correct theta. Because if you get the angle wrong, everything is going to be wrong. Everything. So let's look at our formula for finding the area of a sector. Area of a sector. So area of a sector is given by the formula theta out of 360 degrees times pi r squared. Theta out of 360 degrees times pi r squared. But assuming this diagram, you are asked to find the area of the minor sector. The theta you are going to use will be different from finding the area of the major sector. Take notes. So the theta is very, very, very important. Now, for the radius too, at times the person will not give you radius, but they can give you diameter. If you are given diameter, just divide your diameter into 2. Just divide the diameter by 2 to get your radius. Don't get any challenge about memorizing this formula. It's not any big formula. What you must know is that when you talk about a circle, the area of a circle, we all know that area of a circle is pi r squared. Area of any circle is pi r squared. Area of circle is equal to pi r squared. That is the area of the full circle. But since we are looking at only a sector of that circle, that's why we are multiplying the pi r squared by this fraction. The 360 degrees is the total angle in a circle. Since they are meeting at a common point, we know that angles at a point is 360 degrees. So the theta divided by that angle multiplied by pi r squared. So please take notes. The moment you see area, area, don't forget it is pi r squared. The one mistake that students make is that they normally write the area as theta out of 360 degrees times 2 pi r. Even the 2 pi r alone should tell you that I'm not calculating for area. So please take note of the formula. Theta out of 360 degrees times pi r squared. Alright. So this formula is not used for area of a sector. So let's take a quick look at a sample. Let's take a quick look at the sample. Assuming in exams you are given a question like this, let's make the radius 7 centimeters and let's make the angle here 60 degrees. If you are asked to find the area of this sector, the theta has been given to you to be 60 degrees and the radius is 7 centimeters. So what you are going to do is that you just do substitution into your formula. So we know that area of a sector is equal to theta out of 360 degrees times pi r squared. So theta is 60 degrees divided by our 360 degrees times, you take pi to be 22 out of 7. As usual, take pi to be 22 out of 7. So we get 22 out of 7 times our r, which is 7 squared. I'm ignoring the units. I'll bring it to my final answer. So take notes. You can just ignore them and bring them. They are all in centimeters. So 7 centimeters times 7 centimeters. So if you expand it, you are going to get 60 degrees out of 360 degrees times 22 on 7 times 7 times 7. Please make it 7 times 7 before you start your cancellation. Don't go and cancel anything there. No. Some of you can go and write 7 divides here 1, divides here 1. Then you get 1 squared. It is wrong. You don't do it like that. So take notes. Alright, so after expansion, you can just cancel out. 7 cancels out. Degrees cancels out. So 60 out of 360. You can just cancel your zeros. So 6 divides itself, 1 divides 36, 6. So you get 1 out of 6 times 22 times 7. You further divide it. You can divide by 2. So 2 here, 3, 2 here, 11. So that we get 77 out of 3. You divide, then bring your units. The unit will be in centimeters squared. Because it's talking about area, please. Area is measured in squared units. So 77 out of 3 centimeters squared. You convert it to a decimal. They can ask you to leave it in one decimal place or maybe 3 significant figures. You take notes so that you leave it in the appropriate form in which they want. So that's how you're going to solve it. They can also give you a question. You already know the formula, but if you don't take care, the question that they can give you is going to confuse you. They can give you a question like, look at this diagram very well. You can give you a question like this just to confuse you. Let's say I can give you here to be 300 degrees and I'll give you radius 7 centimeters. They can ask you that the diagram here shows a workpiece that is going to be used to do a particular job. An area has been cut off. So they want you to find the area of the region that has been cut. The area of the region. So a question like this, you should know that you are not finding the area of the figure that you see there in general, because they are talking about a cut. So this portion here that has been cut, you can see that V portion there that has been cut off. That's what you are finding. So to find the area of that portion, which theta are you going to use? So if you are presuming that you are going to use a 300 degrees, it is very, very wrong. You get 0. So the region that has been cut off is not having an angle of 300 degrees. The 300 degrees here is the angle above it. which shows the theta for the major sector. So this 300 degrees here is for the major sector. But because they use the word cut, this cut here, they are finding the angle. Since they meet at a point, you can represent by a variable x. You sum them and equate to 360 degrees. So you first find your theta. Theta, okay, let me use the theta so that you don't get confused. Theta. So the theta will be equal to 360 degrees minus 300 degrees. So that we get our theta to be 60 degrees. Are you seeing? So you need to take notes about questions like this. In some questions, they can ask you to find the area of the figure. That one too is there. They can just remove the cuts. You can get a question like this. 60 degrees. And they'll ask you to find the area of the figure above. Just that. Find the area of the figure above. That one too, you should know the theta you are going to use. It's very confusing, but it's not that difficult. This is the figure that they've drawn for you. They said the figure. So this figure here is a sector. And it's a major sector. So you can't use the 60 degrees for it. You are going to use 300. But they won't give you that 300. So take notes. So if you are finding the area of this figure, calculate the theta, which will be 300 degrees. So that you do just common substitution into that same formula. So theta is 300 degrees out of 360 degrees times your pi r squared. So that's it. Times your pi r squared. So please, I'm begging you to take note of the theta, whether you are finding a major sector or a minor sector. And also read the question very carefully. Not that the moment you see the question, find the area, then you start 60 out of 360. No, you'll be getting this wrong. So take note of it. So that's it about the area of the sector. So note this formula and identify the theta that you'll be using. Now we have also length of arc. Length of arc. The length of arc is what we normally use the theta out of 360 degrees times 2 pi r. Take note, that one is theta out of 360 degrees times 2 pi r. The reason why we are using the 2 pi r is that it's talking about length of an arc. And we know that arc is a part of the circumference. As I said earlier on, if I have a circle like this, any part, if I take a portion from here to this point, it's an arc. So it is just a part of the whole circumference. That's why we are using 2 pi r. So theta out of 360 degrees times 2 pi r. That's it. And also you need to know your theta very, very well. They'll give you the theta. So if here is your theta, take note whether you are finding the length of minor arc or the length of major arc. Take note. Either minor arc or major arc. So if it's a minor arc, you are going to use the angle here. If it's a major one, you use the reference angle outside it to find the major arc. So that's it. And the last one is the perimeter of a sector. Perimeter of sector. So perimeter is the distance around the figure. You know already. Perimeter is the total distance around the figure. So let me just take out the sector from the circle. This is the sector. So if this one is a sector, here is R, here is R. Here is an arc. It's an arc. So the perimeter of this sector here, I will add all the distance around it. So R plus the length of the arc. So perimeter of the sector will be R plus the length of arc. Length of arc. And we know the length of arc to be theta out of 360 degrees times 2 pi r. Therefore, R plus R gives us 2r plus length of arc, which is theta out of 360 degrees times 2 pi r. So that's the formula. So you can take this work and be trying so that you work with it to know how you get your answers. So you draw this and try your hand on it. I'm giving you 220 degrees here. I'm giving you 14 centimeters. Consider the diagram above. Consider the diagram above and calculate I. the length of the minor arc, II, area of the major sector, and take pi to be 22 out of 7. That's your assignment. Thank you very much. I hope you understood it. All right.